Hello, everyone. Welcome back to the next video build hackathon. Today, we have a workshop with Aptos. Before we jump into the workshop, I just would like to introduce myself. I'm Jamie. I am the program manager for the hackathon. And I would just like to say, if you like one-to-one support, you feel free to book a call with me over the next couple of weeks. I'm just going to post a couple of links that will help you get started with the hackathon, including our Discord, the sign-up page, and the Hacker Pack, which has all the links you need and all the key dates. I will now introduce our very special guest. We have Bo from Aptos, who's going to be giving us a workshop titled Getting Started on Aptos to do with, and I will hand things over to Bo. So over to you.
Nice to meet you guys, and thanks for the opportunity to present like Aptos and its token standard. Yeah, I'm Bo. I'm an ecosystem engineer working at Aptos. For today's presentation, so it basically consists of like 3 parts. First, I want to give a brief intro of Mu and especially Mu on Aptos. And then we'll dive into the overview of Aptos token standard. And finally, we'll give like a simple NFT example to give you a concrete idea how to build a NFT contract on Aptos. So first, like Mu is the smart contract language we used on Aptos. So first, like Mu is designed as a smart contract language. So it's deterministic, which basically means we don't have this dynamic dispatch, and all the smart contracts behavior can be clearly reasoned from the code itself. And also as like a smart contract language, it has this built-in gas schedule to support this immediate execution to calculate the gas cost for when you're running a smart contract on the Mu VM. And also one thing special about the Mu is the data is stored on the owner's account, which is different from like Solidity, that the data is stored at the program's account. So with this like data stored at the owner's account, so this data can flow freely from one account to one contract to another contract. For example, like we have like a token contract which has a token store. The owner can store that token into this token store, and they can also like withdraw the token from that token store and give the token to another like a contract, for example, a marketplace contract, where it can take this token and store it in the listing and list it for sale on the marketplace. And also we support this Mu prover, where the user can write a spec for that smart contract to specify some like abort conditions or various kinds of invariants, which is more comprehensive compared to like just write unit test where you can only test a specific input and output. Besides that, as we mentioned, like one key concept of Mu is this resource safety. Basically, in Mu, as the data is stored on the owner's account, so it provides some built-in constraints, like its abilities, like to add constraints to this data structure to make sure that the data cannot be duplicated. For example, if I have a coin, so the smart contract basically cannot like duplicate a coin to create a copy of the coin. Also, it has like ability to prevent a drop. So like the smart contract can like randomly drop a coin during its execution. So the coin's destruction or the token's destruction has to be through like a destructor, like in the explicitly in the contract. Lastly, so the Mu is platform agnostic. So Mu itself is a very lightweight core language with its with a virtual machine, and for different blockchains can build a adapter to adapt this like core VM and language to its chain based on its like execution logic and storage logic, and also like doing its own different type of transaction verification and validation. So after talking about Mu, and then we can look at this like a Mu storage model. So basically data is stored on the account. Aptos, like an account's address is 32 bytes address. And we also like at the early days, we separate the address from authorization. So we have this 32-byte address for an account. We also have a 32 bytes authorization key, where the owner can like later, if we want to rotate that key, they can change that authorization key without affecting the address. So like within an account, so data is indexed by the type, and also we support this generic type. For example, we have an account here, which is like AB61. It has two resources which are keyed by that type. For example, a token store. So which is like the struct type for storing all those like NFTs, and also we support like this generic type. For example, Aptos, there are different types of coin. So each coin type can be passed as a generic type to this like coin store like struct. So it became a new its own type. So for each new currencies a coin store, that will be a new resource and keyed by a different type. So on Aptos, not only data, but code is also like stored under an account address. Based on previous example, right, we have this account, we have two resource. So the token store resource is actually created by calling a function like calling this like initialize token store function. So this function is basically like stored at like 03 account, and it's a function inside of this module token. So the code for initialize the token store is actually stored on the this 03 account. So, and you can see that like with this Mu code like stored at this 03 account, it can manage the data structure that it created under another account. So basically this decouple the data ownership from the management. So basically the data is owned by this AB61, and but the data can be read and write through this code stored at the 03 account. Okay, also on Aptos, like a code is deployed on Mu package granularity level. Basically, a Mu package, we can say create as a set of like Mu modules, like with a TOML file specify the dependency and the address. So all these like Mu modules under the same package will be published at the same address. And also a package can be marked as upgradable or immutable. So if a package is upgradable, it can be replaced by a package which passes this compatibility check. So we have some like built-in compatibility check for you to help you verify if the new module is backward compatible with the previous module. Like this backward compatibility check will basically check will allows you to add new functions and add a new struct, but you cannot like modify the function signature of an existing function. Also, you can like add a new field to some existing like data struct. Yeah, also like when you publish a package as immutable, like Aptos will also ensure that all the dependencies are immutable. So this just guarantee that this immutable package, its behavior will consistent over time. Okay, then Aptos we also like sometimes we want to like one account to manage and own a large amount of the data, like Solidity. Like so for this purpose, we have this like a table data structure, which is essentially a map. For example, like previously we have a token store resource stored on an account. This is essentially a table. So it maps a token ID from the token itself. So the token ID is essentially consists of like three components on Aptos. It's like creator's address, like a collection name and a token name. With this like a unit format of token ID, so we can store all kinds of different tokens in one like a token store. So because like one can like have like thousands of 10,000 of tokens in that token store, so we use this table data structure for this token store. And one thing to pay attention to is for this table, like each key value pair are its own resource. So like so you can read and write these different entries separately. On the contrary, so if you use like a vector or like a data structure or simple map data structure on Aptos, all the like storage are a continuous like a segment. So you have to read and write the entire blob at the same time. After talking about the data structure, so Aptos, like a transaction is executed by calling either an entry point function in a module or like a script uploaded to a chain. So a script, in this script, basically you can like write call any like a public function on on any module. Also, like a transaction can take one or more signers as parameters. So like these signers are like authorization tokens for the like account that signed this transaction. Basically, currently we only support like a multi-agent transaction for this like a multiple signer use case. In this multi-agent transaction, we can that can be like two signers for this transaction. So to so that these two signers both like sign this transaction and authorize this transaction. For the rest, like there's only one signer or no signer for the rest of the transactions. In Mu, the data can only be published to an address if one has a signer for that address. So Oh, yeah, only when you acquire the signer of that account, you are able to create a new resource on that account. And also based on the signer, there can be many derived authorization schemes. So we can have, for example, you can have a simple like access control list, which checks whether the address is in the allowed list. And also you can use like a capability-based control. So like, for example, for the authorized identity, it can acquire a capability token, capability struct, to authorize for like the functions that only authorize based on the capability. For example, if you want to burn a coin, so the coin burning function takes burn capability. So for anyone who wants to burn the coin, he can use either signer to first acquire the burn capability and then use that burn capability to actually burn the coin. And another important building blocks on Aptos is called like a resource account. In this resource account, you can think it out as an automatic account, which basically it stores this like a sign capability, and later when like a user request comes in, it doesn't it can automate this contract can create the signer from the stored signer capability to authorize some functions that requires the original signer to run. So by having this like resource account, so these smart contracts can perform this automatic operations without the actual account owner to sign every transaction. So for example here, like this code basically demonstrates like we can like create this resource account and directly publish a package. For example, it calls this like create this resource account, and this create resource account like return this resource assigned capability, and this is the data struct that can be stored by this resource account, and use it later to create a signer when needed. And also another important like access like control is like this like off-chain sign proof. For example, we can use like this like this use this to authorize the ones who have the signature to like mint NFTs or create NFTs on behalf of the original creator. So it requires the caller to pass in a signature. So this signature is basically generated by the original like creator or who has the authority. They can use his private key to sign or to encode a message, and then whoever got this like signature proof can pass it into this function, and on chain we can use the public key to decode this signature and to read the original message, and to verify the message whether it matches the current, for example, the one who wants to mint the token. If it matches, and then we can, then this person have the authority to mint the token. So by doing this, like off-chain, signed proof, we don't have to maintain a gigantic whitelist on-chain, and it can save the space for the smart contracts. And after like giving some the general introduction of the Mu and some like building blocks, we can go detail into the Aptos token standard. So basically, the reason why we have a token standard is basically we want have the improve the liquidity of the token on Aptos so that these tokens can be created, stored, and traded in the same way. So that's the main reason we have this standard, and also there are mainly two major use cases these days. Like one is use the token as a currency. The other major use case is to use it as an NFT or some utility token. So these two different type of use cases, they often like have different, like for example, for the currency, the metadata is usually very simple and immutable. And for the NFT and utility tokens, they usually require customized properties, and also these property values may mutate over time. So based on these two differences, so we have like two modules. One is called like a coin module, which is especially used for the currency use case. It only support very limited metadata field, and also this field are immutable. And for the second like use case, we have this token .mu. It support like more like metadata, and also the creators can specify their own properties, and each token also have the value for these different properties, and also these properties can, or the metadata field can mutate based on the config. So this is so since the currency like use case is simple, so like let's directly dive into the token module. And for this token, so this is the a very gigantic figure of each data model. So you don't have to pay attention to the details, and we will just give you an overview, and we will go through some like key components in the following slides. And for the token, basically on Aptos, there are 4 major like LifeCycle events, like this, like token creation. Aptos, like when you create a token, like it has always be, it has to be belong to a collection. So first you have to create this collection, and you create a token under this collection. And after creating this token, you can mutate the token metadata field and properties. For example, a token, it can have this like maximal, the maximal number of the tokens can be minted. So you can like mutate this metadata field, and also a token can have properties, and you can also like mutate these properties, etc. And also you can transfer this token from like the original creator to a collector, or like they can transfer these tokens among themselves. And finally we have this token burn, like LifeCycle. So they can the creator or the owner of the token can burn the token. let's first dive into this token creation. On Aptos, like a token standard, when you create a token, so you first like create this token data struct, which is the data struct stored at the creator's account, which you can think of essentially the type of this token. It has all those like metadata field. For example, the maximal, which is the maximum number of the tokens can be minted with this token data type, and the current supply of this token, and the largest property version, which is like indicates the current different like different version of properties like for this token type. And the URI is basically you can point it to a JSON stored in some option storage, which contains the like image URI or like video URI, and whether like this is like stored in some like CDN. And also you can have this like a royalty, which basically specify the percentage that when you transact this trade this token, how much the total price will be paid to the original creator, and the name of the token and description, and also there's default properties, which is basically a key value pair, a key value store, which the key is the property name and the value is the property's value. And we currently support different primitive types. Like we support like number type and a string, address, boolean, and raw like bit blob. And these default properties will be shared by all tokens created with this token data type. And we also have this like a mutability config to specify which like field are mutable that can be changed later by the creator. And then we have this actual like a token struct, which consists of like the ID of the token and the token properties and the amount of the token. So for the token properties, which is also a property map, which is a key value like store, the only difference from the default properties stored in the token data is like token properties can have different values. From the default properties, you can think of like all the tokens initially have the same value, but different token goes through different like mutations. After that, they can have different value from the original default like values. When you're creating this token, so you can store both the properties on-chain, like for example, you can store the properties in the default properties, and you can also store the properties off-chain. For example, you can have a URI point to the JSON file stored in some off-chain storage. So currently, we have collaborated with a bundler network. So you can use it to upload this like a JSON or your image or video to Aviv and pay through this Aptos coin. So then we can talk more about this token mutation. First, like we can talk about mutating the token data field. So as we mentioned, like this token data is a struct contains the metadata field that is shared by all the tokens created with this type. So we currently support the mutation of like the maximum, like the maximum number of the tokens that can be created from this token data, and the URI, and the royalty, and the description, and also the default properties of this token data field. So some of them are already on the mainnet. For example, like mutating this URI or mutating this properties should already be in the mainnet. And for the mutating the maximal and the royalty and description, it should be released in like in the coming mainnet release. And also, besides mutating this like a token data field, you can also mutate the properties stored at the token itself. So this is controlled by a property stored in the default properties, which is a token data field. So, like for the demonstration purpose, so we can take a look at a simple example for this like a token property mutation. For example, like in a game, and originally like we can have like a shield token. Like for this shield token, like the game developer originally, for example, minted to 20,000 this shield token, and they all have a default property called durability, and it has a default value called 3, and we use this property version to indicate, okay, this is the default property that initially created. And once this token, like the shield token, has been given to the players, like each player can like use this token in the shield token in that game. For each use, the durability will decrease. For example, for the player A, like he uses the shield twice, and the durability drops to 1. So that for the token properties like stored as a token itself, the properties value drops to 1, and we also like meanwhile give this like property version 1 to differentiate it from the original like a fungible token. So afterwards, this token can become you can think of it became a semi-fungible use case. It mutated from the original like a 20,000 like a fungible token to a now an NFT with its own token ID and its own property value. Similarly, for the other and the player B, he can also have a like a shield token, which can have a different like a value for the durability property. And after like one use of this shield token, and it also has a property version, and to differentiate it, like this player's token from the rest of the tokens. So this is the token mutation, and we also like for the token transfer, we have different mode of like a token transfer. For example, we have this like a safe transfer where the sender offer receiver a token, and only when the receiver claims the token from the sender, the token appears in the receiver's token store. So the reason we have these two steps is basically to protect the receiver from getting some like unwanted, like explicit NFTs suddenly show up in their wallet like without their consent. And also we support like this. The second mode is transfer with opt-in. So the token receiver can opt in this direct transfer. After they opt in this direct transfer, like anyone can directly send an NFT or token to the receiver's token store. Also, the receiver, if they don't want, they can opt out afterwards. And the third mode is basically this multi-agent transfer. So this is the previous like transaction type we mentioned. It could take two signers. For this transaction, like it's a transfer, it requires both sender and the receiver to sign this transaction, and then this token transfer can directly happen afterwards. So lastly is for the token burning. So this token burn, like by default, no one can burn this token like after it's created. But there are configs in the token data default properties. The creator can allow for example, the collectors to burn the token, or they can also like turn on the config to allow the creator to burn the token. So all these like configs are created when the creator created this token. So lastly, we can take a look at a simple like NFT airdrop example, just to give you like a flavor of what the actual contract looks like on Aptos. So basically, in this like use case, like NFT creator want to basically deploy the contract on chain, and the selected users can claim the token from the contract. So the requirements basically would be, okay, the user can claim the NFT without the creator to sign in the transaction, because there are potentially like tens of thousands users want to get a token from this creator, and the creator can like manually sign all these transactions. And also we want to like mint a large number of NFTs and with a sequence number. And also the creator want to control like who can claim the NFT from his contract. So this is basically a simple example we have. Yeah, I will just walk you through some like key components. For example, as we mentioned, like we have this module, and which is stored on the owner's account, and also like in this module we can have some like a struct, which can store different like properties for this like NFT airdrop. For example, the public key, the token that people can create, and when this like airdrop like expire, and whether it's enabled. And then when they set up this contract, like deploy this contract, they can call this init module, which will be automatically run when people deploy the contract. And in this init module, it will basically just prepare the token to be created, and create this token. And also one important part is it store the sign capability. Store the sign capability on this account. Later, when people tries to mint an NFT from the creator's contract, they need to pass in some signature proof to verify their identity. After verifying the identity, and the contract can acquire the signer from the previously stored the signer capability, and with this like a signer, then the contract can mint the token on behalf of the creator and transfer the token to the user who tries to get a NFT from this collection. Yeah, this is a brief walkthrough of one concrete example. You can take a look at more detail that is linked. And also, like as mentioned, you can store these properties on chain. For example, when the people tries to mint the token from this collection, we can actually store some properties like a gifted to is the property name, and the value is the receiver's address, and we can store it as an address type in the property map, and store it in the token that we give to the receiver. And this is all about today's talk, and you can check more details at, like, we have more examples in our repo, and we have this token standard doc, and we have more developer tutorials. And if you want to get the latest updates, you can check our Discord. And also we have this Moon Monday every week to talk about the latest and most exciting things going on at Aptos. Yeah, I think that's all.
Awesome. Thank you very much, Bo. That was super interesting. And I'm sure you've inspired loads of people to build on Aptos. So we'd just like to say thank you very much for coming in. I don't think we have time for questions today, but if you join the Discord, you'll be able to get support for the hackathon, either on our Discord or on Aptos Discord, I'm sure. So yeah, thank you very much, Bo, for coming in.
All right. Thank you, and it's my pleasure. Bye.
Awesome. Have a good day, everyone. And the recording will be made available tomorrow as well if you've missed any of it. Have a good day. Goodbye.